Hey, listeners, great news that you don't want to miss. On April 8th, Pam is doing a webinar with our friends at Number Club.
We're talking about games that make kids want to think, not just memorize.
No drill, no mindless repetition.
Just real mathematical reasoning disguised as seriously fun games.
If you've ever thought, my students can do the steps, but they don't really understand,
Or if you thought, my students can't do the steps and they don't understand, y'all, this is for you.
register here, www.mathisfigureoutable.com/numberclub-games-webinar. That's mathisfigureoutable.com/numberclub-games-webinar.
Come and see what true fluency actually looks like. Now, on to the show. Hey, fellow mathers, welcome to the podcast where math is figure-outable. I'm Pam Harris, a former mimicker turned mather.
And I'm Kim Montague, a reasoner who now knows how to share her thinking with others. At Math is Figureoutable, we are on a mission to improve math teaching.
We invite you to consider that algorithms are amazing historic achievements, but they are terrible teaching tools because mimicking step-by-step procedures actually traps students into using less sophisticated reasoning than the problems are intended to develop.
In this podcast, we help you teach mathing, building relationships with your students and grappling with mathematical relationships.
We invite you to join us to make math more figure-outable. Dum-dum.
Hey there.
Okay. So I actually had a lot of that memorized because I had forgotten to scroll up on
Good for
so
you.
I was like scrolling as I was like, okay, what is the beginning?
I mean,
of this?
seriously,
Right,
this is the 303rd episode. You would think I mean, I know we switched at one point in a couple years in, but you would think that
we did write a new. Do you think we'll ever write another new beginning? Probably, right? We'll shift.
Oh yeah, sure.
We'll do something new. Yeah. Uh-huh. All right, cool. So Kim, you and I were chatting a little bit about what we were going to do in the podcast, and I shared a recent experience with you, and we thought we would bring it to our podcast audience because there's some interesting things that happened, and I wanted to parse out a little bit what you thought about it and what I think, and kind of where we go from here. So I was doing a workshop, and I've done several in-person workshops lately. I don't do as many of those lately, but Anyway, blah blah blah. I was doing an in-person workshop with some wonderful educators. We had kind of ranged the gamut. We had everything from they were mostly secondary, 6th grade up through. We had calculus teachers in the room, but we also had an interventionist, GT specialist. We had the assistant superintendent for curriculum instruction. And I'm not actually quite sure, but we had a social studies expert. So, quite the range of people in the room. It was a great group. Had a fantastic day. In the day, I started the day like I often do, telling the story about my kid when I was talking to my kids' teachers, and they said, "Hey, we've heard we don't want to give kids math anxiety, so we should stop giving kids time fact math tests." So we stopped giving them time fact math tests because we don't want to give them math anxiety. But now we're noticing kids don't know their facts anymore. Is that important? And I was like fussing with that. I'm wondering, is that important? I wonder, does my kid know his multiplication facts? So I go home, I ask him, just pulled one at random. Do you know your fives? He's like, no. I'm like, what? You don't know your multiplication facts? Sort of really generalized. If he doesn't know one sort of factor of multiplication facts, then he doesn't know any of them. And I'm panicking. Yeah, I'm panicking. And he says, Mom, you don't have to know your fives if you know your tens. And in that moment, there was this mind blown, of me thinking, wait, what does it mean to know your multiplication facts? Do kids need to have them memorized, or would I rather have this confidence and relationship owning that you don't have to know your fives if you know your tens, because you can just multiply anything by 10 and cut it in half to get times 5. And he even did it with times, double digit numbers. And so it was this mind blown moment of me thinking, wait, what does it mean for kids to know their facts and how, what's more important? And that's the main kind of message of that opening story. And I asked participants, what's resonating for you, or what do you have a question about? And a couple people said that they were grappling. It sounded like they were grappling with the same thing. Like, we have this feeling that kids need to know their multiplication facts, but wait, we're kind of interested in what your kid was doing and blah, blah, blah. So later we went on, we did a bunch of problem strings. We're doing a lot of work. And at one point, we're doing a problem string, and one of the participants raised their hand and said, but wait, this stuff that we're doing right here, how's that going to help kids know their facts? Weren't you worried that kids don't know their facts? And I was like, yes, but remember there was this epiphany that we're grappling with. What does it mean for kids to know their facts? And it was just interesting that as we were doing these problem strings to really build relationships so that strategies became natural outcome, at least one of the participants was still grappling with the work that you're doing. I think this person clearly heard at the beginning, kids need to know their facts. Maybe didn't hear so much the conundrum, the grappling with what does that mean and how much, and does it really mean they need to, and so they were kind of bringing it back up. Well, wait, this work that we've just been doing, this isn't helping kids know their facts. And I was kind of like, yeah, but what is more important? So that went on. It kind of came up again. We I was trying, Kim, I tried really hard in professional learning situations. I think you do too, to not just tell people stuff and then try to prove it, but to try to engage people in experiences so they come to the realization themselves, right? I raise some ideas, we do a bunch of math, and they start to go, wow, we can really see how it's more important that kids build these relationships, because then they're going to own, I think you've said it this way, they're going to own enough facts that then they can build from there to ones they don't know, including ones that we don't traditionally think that they should know. Anyway, that's going to come up a little bit more in my story here. So later in the day, I did a factor to subtract strategy. Now, we've done that on the podcast before, so maybe we can link in the show notes where we've done that if you want to go listen to that, but I'll replay it a little bit enough here that we can kind of get a feel for what's going on. So for example, I might give a problem like 77 minus 50 and just really quickly throw up a number line, 77 minus 50. And that, what is that? Is that 27? Help me, Kim. I'm doing it live here. And then if 77 minus 50 is 27, then the next question is 77 minus 49. And obviously, maybe I shouldn't say obviously, but because I've put up that 77 minus 50, a lot of people then will try to use 77 minus 50 to help them think about 77 minus 49, which is fine. And we talk about that over subtraction strategy. But then there's this punch where I'm trying to accomplish a couple of things in this problem string. And the next problem is, what is 11 times 7 minus 7 times 7? And I'll even say something like completely unrelated, totally unrelated to the problems before. And then I'll smile a little bit and I'll say, was anybody a little lazy? I mean, efficient? Were you acting, doing a mathematical behavior where you're trying to be efficient? And usually somebody, and in this day, somebody said, well, yeah, once I started to think about 11 times 7, that's 77, minus 7 times 7, that's 49. I remembered those numbers. It's almost like we've just solved this problem. Well, sure enough, it was the problem before. And so then they're like, yeah, I was a little bit lazy. I just said, since we've already solved that problem as 28, then I'm not even going to do any more work. I'm just going to say that 11 sevens minus 7 sevens is 28. And I'll say, great. That's a great strategy. And I'll try to pull that one out first. And I did. And then I'll say, but did anybody not do that? Did anybody not just say, oh, this is like the problem before, so I'm just going to take the answer from the problem before? Did anybody actually think about 11 sevens minus 7 sevens? If you have 11 sevens minus 7 sevens. And usually in this day, sure enough, there were a couple people that kind of grinned. And I was like, you're grinning. Like, tell me about that. They're like, well, yeah, like 11 sevens. They said, I didn't even think about the subtraction problem before. I just saw 11 things minus 7 things, and that's 4 of those things. So 4 sevens, and I know 4 sevens is 28. Bam, and that's kind of how they solve the problem. Often when this happens, and this happened on that day, a lot of people in the room kind of raised their eyebrows, and they were like, that didn't occur to me. And I'm like, that's okay. It's all right, cool. Here, next problem. Then I give them another problem like 81 minus 40. We do the number line for that. Then we do 81 minus 36. We talk about, can you use 81 minus 40 to help you think about 81? Again, I'm ramming through this, Kim, because you can go listen. If you haven't heard this problem string, go listen to the problem string. Could you use 81 minus 40 to help you think about 81 minus 36? Often people are smiling who hadn't seen the relationship before. They're thinking about this over subtraction strategy. They're, like making these jumps and stuff. It's great. And there's also a couple people that are kind of winking at me a little bit. And sure enough, there was these 2 guys that were sitting at this one table. And I was like, why are you smiling? And the one guy, I think his name was Chris, maybe, he said, well, 81, that's like 9 nines. And 36, that's like 4 nines. So 9 nines minus 4 nines is 5 nines. And 5 nines is 45. And I'm like, that's actually how you solve the subtraction problem? And he's kind of like, yeah. And a lot of people in the room are like, what? And he's like, yeah, it's just like nines are popping out at me. 9 nines minus 4 nines is 5 nines. And so 5 nines is 45. And so I think the answer to that subtraction problem is 5 times 9 is 45. So then we did a couple of more problems and everything. So as we're doing this problem string, that same table that kind of pushed back earlier, but wait, don't we want kids to know their facts? Again said, well, this time kind of almost triumphantly. It was kind of interesting. They were like, see how important it is that you know your facts? And Kim, I was looking at the board and I was like, say more about that. And they said, well, Pam, in order to solve 77 minus 49 using 11 times 7 times 7 times 7, you had to recognize that 77 is 11 times 7. And like you had to recognize sevens. And to solve 81 minus 36, it had to ping you for nines. And so we have to teach kids multiplication facts. What's interesting then is, so I kind of let that push back. I kind of raised it. I was kind of like, okay, that's interesting that you're sort of saying that. And then I threw out the problem 144 minus 96. And I said, what do you got? For 144 minus 96, what could be a way that you could solve that problem? And several people around the room who'd never messed with over subtraction started thinking about 144 minus 100 and going from there. So I'm circulating around, I'm asking people, but also several people heard 144 and they thought, ooh, that's 12 12s. And so as I'm circulating, I found a group and I called on them and they said, well, we can think about 144 as 12 12s. And then 96 as, and we kind of had to think about that because we didn't actually, a couple of them were like, we never memorized our 12s. And I was like, well, could you think about 96? And they're like, yeah, we thought about 96 as a few less 12s. And sure enough, it was just 8 12s. There was a couple different ways that they figured out the factors of 96. Noteworthy, they didn't know that 96 was 8 12s in the moment, but they were able to reason quick enough that it didn't bog them down in the work they were doing. And so then they shared. So then it's 12 12s minus 8 12s. That's 4 12s. And 4 12s we know is 48. And so the answer to the 144 minus 96 is 4 12s. And I said, oh, that's fantastic. Like, I love how multiplication is pinging for you. This is great, great. I wonder, did anybody have any other facts? Any other, not 12s? Anybody have anything besides 12s that pinged for you from 144 minus 96? I let him go. I let him loose. I circulate around a little bit. I'm watching. Kim, it was fascinating. The group that was really focused on kids need to know their facts. Like they kept like, see, the work you're doing isn't helping kids memorize their facts. When I invited them to think about other factors that pinged for them for 144 minus 96, they had nothing. Now, I'm not blaming them or ridiculing them at all. It's just noteworthy that they were so insistent that it's how important it is that kids memorize their facts because they memorize their facts. So for example, at some point I said, hey, what else do you got? And somebody said, well, I can think about 24s. And I was like, tell me about that. And they said, well, if it's 12 12s to make 144, in fact, Kim, maybe I should ask you, how are you thinking about, if you know 12 12s makes 124, how does that help you think about how many 24s make 144?
So if I have 12 12s, then I could have 24 6s because I have twice as many where the group size is half as big.
Nice. Nice.
Say that again.
Yeah. Or similarly, I could have half as many. So 6 groups where the groups are twice as big, 24. Yep. Now I have 6 24s. And then if let's stay there. So because I want to talk about 24s.
Yep.
So, or we could really go either way. I'd love your way. And then this other way, thinking about 24 6s or thinking about 6 24s. Could you similarly think about 8 12s? If I know that I have 8 12s, how many 24s do I have if I have 8 12s?
4 24s. Did you say 8
Why?
12s?
Yeah, 8 12s.
Okay, yeah.
Why do I have 4 24s if I have 8 12s?
Because I have half as many groups that are twice as big.
Kim, do you build that kind of intuition, rote memorizing single digit facts?
No.
So you
No,
don't, right? How do
no.
you build that kind of intuition? You build that kind of intuition when you're trying to help kids really own multiplicative reasoning. And so
Yeah, for sure.
you're in and out of these relationships. So now we end up with 6 24s minus 4 24s. That
Hmm.
is at 2 24. Hey, and
Yep.
2 24, that's also 48.
Yeah.
So in that moment, guess what that table shot back with? That table shot back with, yeah, but we don't expect kids to know their 24s.
Yeah.
In the reasonable things that we,
Yeah.
they didn't
Yeah.
even say reasonable. What they said was the ones that kids should know. And I was
Right.
like, I mean, like, so what's magic about the multiplication table up to 12s? Because we just had teachers right here that admitted they don't know their 12s. And oh, bless his heart, it's when one of the calculus teachers raised his hands and says, yeah, I don't actually know my 12s. And I was like, so that's noteworthy. We had a calculus teacher in the room that
Yeah.
doesn't, is fully admitting doesn't know his 12s. Oh no, he's going to fail. He's not going to be successful. Or are there more important basics? Are there
Yeah.
more important things that we can help kids? Like, Kim, the reason I said basics is you and I have been talking lately about how there's some folks out there, some people out there that are saying it's really important that kids know their basics before they can do any kind of reasoning with
Yeah.
mathematics. And we're going to maybe redefine what those basics are.
Hmm.
And it's things like we just did, where if you know 12 12s, can that help you think about how many 24s you have? Or Kim, can you go from there? So I'm just going to see, like, what else you got. We got 12 12s minus 8 12s. We got 6 24s minus 4 24s. Can you think of any other factors that we could pull out of 144 minus 96?
Yeah. You can
I
do
know.
348s.
Okay, so we got 3 48s minus,
Is that 2 48s?
I don't know, is it?
No,
Three
I didn't
forty
write
eights
anything
minus two.
down, so I wish I would have
You're in
this
the
whole
air.
time. Yeah, I think it's
Ah,
two
so
eight
that'd
twelve,
be
so four
148, and
24s. Yep. Uh-huh.
I like what you just did, but I also just checked to see if we got the right answer. Like 3 48s minus 2 48s is 148, and
Yeah.
sure enough, the answer has the whole time has been 48.
Yeah.
So now I do wish you'd been writing it down, and this is one of those moments where the visualizing up me recording thinking would be so important.
Hmm.
So once I've got 12 12s minus 8 12s and 6 24s minus 4 24s, yeah, can you come up with any more? Now that I know you don't have them written down, that's much harder to do.
Yeah.
I will say somebody came up with twos, how many twos they had.
Yeah.
I know I can do 96 is 48 twos. What's 144 cut in half? Is that 72?
72. Hmm.
So we'd have 72 twos minus 48 twos. And that's when somebody said, why would you do that? And somebody goes, yeah, you wouldn't, but you could consider it. Like, we now have enough sort of relationships happening that we consider it. And somebody said, well, if we know 72 twos and we don't want to do 72 minus 48, like that, but that doesn't make us happy. But once we have the 72 twos minus 48 twos written down, could that help us think about the number of fours? Is that 36 fours minus, and can you see how I'm doubling having here?
Hmm.
24 fours.
Hmm.
Oh, well, that's just 12 fours. Oh, bam, we're back to 12 times 4, which is 48.
Hmm.
Y'all, in that moment, it was interesting to watch that table that was so like set that kids need to rote memorize their facts. Go, yeah, but these aren't reasonable for kids. And I'm like, wait, we're not expecting kids to rote memorize any of these. What we're doing is we're saying, if we build multiplicative reasoning, look how they are now reasoning multiplicatively. Like, and not that as an end product, but we're building it here. Like, we're
Yeah.
continuing to
Yeah.
have kids sort of build from here. Yeah.
So what I love about the string, thank you for sharing that story. And I wrote several notes down that I wanted to come back to, but I didn't interrupt you. So what I love about this kind of string is because you're sharing problems like 81 minus 36 and 77 minus 49 that you could think of the quote unquote basic fact. But when you land with a problem like 144 minus 96, there's so much more richness to it that keeps kids playing and looking for more. And I'm glad that you said that they're building, because you could have stopped at 12 times 12 minus 8 times 12 and just said that is, those are two facts you're supposed to know. But you're deepening their understanding as they're looking for more, and you're building, you probably already said this well, but you're building their multiplicative reasoning. And I'm thinking about the people that you were working with, and I wonder if maybe they've only thought about facts, um and they think about it like, okay, I'm supposed to know this series of facts, and they picture the problem, they picture 9 times
7
4 and
times 8.
7 times
Right.
4.
Mm-hmm.
And they think this type of problem, they have to go through all the facts and see which one lands at 81. Like, I wonder if they saw 81 and they thought, okay, what's the Rolodex of problems? Which one hits on 81?
That I've wrote memorized. Yeah, that hits on
Yeah.
81. Uh-huh.
Yeah.
Uh-huh.
Where you and I would think, what do I know about 81? Like, we're picturing that product, and I think we're calling this like a product approach, because when we picture 81, we think, what do I know about this problem? We focus on deeply understanding a number. So it reminds me, you used to joke, like, when we played I Have You Need a ton early on with teachers, you would say to them, when I wake you from a dead sleep and I say, what do you know about 64? And then you'd rattle off some examples. So, like, what would you want somebody to know about 64?
Yeah, well, and I would usually ask people, and they would come up with things like 60 plus 4, 70 minus 6, 8 times 8. And I would say, keep going.
Yep.
And then they would say, okay, how about 2 times 32 or 16 times 4? And we kind of had to get going a little bit to get the juices sort of flowing. But 8 squared, like, we really want to have a lot of relationships, including 64 plus what is 100. We want to also have that 36 coming out. Yeah. What do we know about the number? Yeah, that's nicely said. That's good connection. Yeah.
Well, and the more that people know about a number, the more flexibly we can move around that number. The more that we see a number and we start to rattle off all of the things. So, like, when you see 144, if you only think 12 times 12, maybe we'd wonder if it's because you've only experienced it by knowing the fact 12 times 12. And we would want richer experiences for somebody.
Yeah, like you and I were just doubling and having and thinking about, how can I go from what I know to something else, which we build when we're not just focused on rote memorizing a small set of facts.
Yeah.
And then we get a whole lot more. Hey, Kim, try just one more with me.
Yeah.
What if I were to ask you 72 minus 48? What comes to mind for you if you were going to solve that problem?
I think I'd think about 9 eights minus 6 eights, because I know those two have,
Nice.
Mm-hmm.
Nice.
Yep.
And so you could also have thought about 72 minus 50 if we were doing the over thing, but cool.
Yeah.
Do you got any other factors that pop out at you?
Let me think. They both have 6s. So is that 12 6s minus 8 6s?
Nice. 12 minus 8 is 4 6s. So that's also 24. I like it.
Yeah. They're both even. So they have 2s as well.
Yep. And I actually doubled and halved and got 18 4s minus 12 4s. So that would be 6 4s. Yeah. And then we're kind of back to the 4 6s. Yeah.
This is such a, this could be such a fun activity to do in class. It's much more meaningful than a timed fact thing. Like,
well, and I'll bring up our friends from Innovamat have they've coined a phrase what they call productive practice.
Yeah.
I think this is an example of productive practice where we're getting kids to really do a lot of multiplication facts, but in a way that it's kind of this product approach and the relationships between the factors. And then if I could just mention, so I'll just take the one that you said, 9 times 8 minus 6 times 8. Could I then say to middle school kids, hey, it's almost like you're saying if you have 9 8s minus 6 8s, or 9 things, and then I write down 9x, minus 6 things, and I write down 6x. You're saying that that's like 3 of those things, and I write down 3x. Now we're helping kids reify an algebraic term that they can look at 9x and know that it's 9 of those x's, and minus 6x, 6 of those x's. And now they're not looking at 9x and thinking 9 plus x, because they have this experience from that we've helped them build before, which just leads, it could even lead to 9 times the quantity x minus 2, minus 6 times the quantity x minus 2. Well, if I've got 9 times a thing, minus 6 times a thing, doesn't matter what the thing is, it could be x minus 2, but I'm going to have 3 of those things, 3 times the quantity x minus 2. Yeah. Like, there's a lot of algebraic thinking that can come out of us really helping kids build these relationships.
Can I say one more thing that I have in my mind?
I mean, I guess. No, I'm just kidding.
So, I think sometimes the argument feels like it's either memorize your facts or don't. And I don't think that that's the case. So
no,
when when you think kids need to memorize their facts the way that we would describe rotely, then we know sometimes that the result of that is either they know them or they don't. And they say, like, I forgot. And they don't have a way to do anything about it. But I think what we're
And a lot of
suggesting
kids
is that
and a lot of kids get math anxiety along with that.
yeah,
But yes,
yeah,
keep going.
yeah.
Keep going. Uh-huh.
So I think what we're suggesting is that when you build relationships and you focus on those relationships, you also can build fluency. We would want you to do work to build fluency. But in
Mhm.
that work, you're also building a deeper understanding of number in the way that we're suggesting a product approach helps kids. And so then, as people will sometimes forget, they can go back to the relationships. They can go back to the facts that they do remember. And it's not just this idea that, like, I forgot that one and I don't have any way to do anything about it. So
Yeah, but I'm just gonna have to guess or type it in
yeah,
my calculator.
yeah.
Yeah. Nice. That's nicely said. Yes, it's not that we don't want kids to know their facts. We want them to more than know their facts.
Right.
Yeah, nicely said. Y'all, thanks for joining us today. We love having you as part of the Math is Figureoutable movement. Thanks for tuning in and teaching more and more real math. Let's keep spreading the word that math is figureoutable.
Thanks for joining us. And remember about the Number Club webinar on April 8th.
Number Club games hit different because kids see the relationships, build the relationships, develop the relationships.
They're planning, experimenting, and thinking strategically.
That's the kind of fluency that transfers.
If you haven't registered yet, there's still time. Register here, www.mathisfigureoutable.com/numberclub-games-webinar.
Y'all come and learn more about the games that make math figure outable and keep making math figure outable.